All right, so here we're supposed to simplify this complex fraction. Well, first things first, we have to figure out what do these to the negative 1 mean? Well, if we have a to the negative 1, that's the same thing as 1 over a. And if we have b to the negative 1, that's the same thing as 1 over b. So really what we have here is 1 over 5 times 1 over a, so 5 over a, plus, and then this is just going to be 1 over b. Okay. Now, here we have to get a common denominator to be able to add them together. So we have to multiply this one by b over b and this one by a over a. And when we do that, we get 1 over. Now that's going to be what? A 5b. And this is going to be plus a all over ab. Okay. Now we're not done yet because, this is really a 1 over 1. So what we're going to have to do is multiply by ab over 5b rather. Let's erase that. All right, so 5b plus a, and same thing on the numerator. And so that cancels that, that cancels that. Now in the numerator, nothing cancels. We just get what we have there, which is just ab over 5b plus a. Okay, and that is our simplified form of our complex fraction here. So this one we had to first make it into a complex fraction, changing those to over a and over b, and then getting a common denominator and then simplifying from there until we get to our final answer. All right, here we have a application type of problem. So it says light bulbs are often wired so the electricity can flow through either bulb as is illustrated in the accompanying figure. Now in this way, if one bulb burns out, the other bulb still works. If two light bulbs have resistance T and S, their combined resistance R is shown below. Okay, and so this is kind of in parallel. It's parallel, and so if this one burns out, then the electricity still goes through here. Now there's one called series, where what you'd have is you'd have a bulb here and then a bulb here, and so if that one burns out, then this one doesn't work either. Or if this one burns out, it doesn't work here. So this one is if one of them burns out, one of them still is going to work. So that's a little physics for you. And so what we're supposed to do is simplify this formula. So it kind of works down to be kind of like the last problem we had. If I write it right anyway, if I rewrite this here, let's erase. So it's going to be 1 over 1 over t plus 1 over s. So we have to get a common denominator here. Well, that's just going to be s times t. So if we multiply this one by s over s and this one by t over t, what do we get? Well, we get 1 over, here we have s plus t over st. Now we multiply by the reciprocal st over s plus t, multiply the numerators by the same thing. Well, that cancels that, that cancels that, and so we just get what's up here. 1 times that is just going to give us st over s plus t. And that would be our combined resistance into one simplified expression. Okay? All right, so that's all I have for this section. So hopefully that helps you get through the homework stuff.